Okay.
Okay, so thanks everybody for joining the webinar today. I'll just take you through our agenda very quickly. So brief introductions from myself and Sean, some highlights from the research that we've carried out over the course of the year, the common challenges that we've identified from global energy managers, how our new Sparks framework will address some of those challenges, and then most importantly, a demo from Sean. So the research that we carried out this year was with over 100 senior industrial leaders in the decarbonisation, energy management and process efficiency spaces. It was a jobs to be done questionnaire of about 35 questions, and it was aimed at really allowing us to better understand people like yourselves as global energy people, and to understand what their pain points and challenges are, and then use those insights to inform the technology choices that we take and the products and solutions that we prioritize in the business. You'll see some stats on the right-hand side. I won't go into those now because in the following slides for each challenge, I'll detail those anyway. So one of the big challenges that came through in terms of a number one is really getting all of your data and all of your information together in one place. That really isn't easy. And as you can see from the stat, 4 out of 5 people ranked that as highly important, the data availability. And then even getting it together in one site is challenging. Getting it together from multiple sites is even more particularly challenging. But you must do it, because if you don't do it, you won't have an accurate picture of your real-time energy consumption or where your emissions are.
Yeah, I mean, we see this all the time, right? For global companies with sites all over the world, you've varying energy prices, varying emissions factors, evolving grids, and then a range of sites that are all at different levels of maturity technologically and culturally. But yeah, again, you have to be able to see all that data clearly to understand what the opportunities are, where they are, what to do when, how to prioritize, and to make those decisions, you really need to have that sort of visibility and those meaningful KPIs.
Okay, moving on then, I think we'd all probably agree that reporting accurately is very important, but it's also very painful. And 80% of our respondents also responded to that fact. So reporting is highly important, but obviously chasing every person in your plan to give you the data you need to put into a report isn't what anybody wants to be doing with their time. And part of the challenge is by the time you've chased all of that data and collated it, arguably it's out of date as soon as you put it together.
Yeah, I mean, the point of any report ultimately is to inform decision making, and in a world where all of these factors are influence energy on a daily basis, you need to be able to make those decisions quite quickly, if not in real time. So having to wait until 5 days after the end of the month to combine your production and energy information is of little value.
Absolutely, your whole world has changed, arguably. Okay, and data itself will only get you so far. It's really the insights in the data that is super important, and that's what really matters. So even if you collect all of your data together in one place, you need to have the skills and experience and tools to really be able to highlight the trends and the opportunities buried in that data. So it's not just about getting your information in a timely manner, but having the skills and ability to understand what's going on under your data.
Exactly. I mean, you have to challenge the data. You have to challenge the KPIs, what they're telling you. So often we see that traditional sort of kilowatt hours per ton of product being the go-to benchmark for energy metrics. But, as a metric, that's simply blind to, all of the other influencing factors that we know about, weather, quality of raw material, product mix, all of those things are influences on energy use, which is why you need a slightly more sophisticated energy model, maybe to take account of those factors. And that process of developing energy models forces you to really look at that process, really understand what your demand is and what's driving demand. And it's kind of transformational, actually, in terms of the insights that fall out of it.
100%. But data is the foundational layer, obviously, but at the same time, data in and of itself will only take you so far. This is a term that we use quite a bit in the business, and it's reinforced by the respondents' answers in the surveys that we did. And that's 76% of respondents are struggling to maximize their decarbonization velocity. So the term we use is executing decarbonization is simple, but it's not easy. So it's not easy to get those complex decarbonization projects across the line, and not being confident in the data you're collecting to inform those decisions is even more challenging. So there's significant roadblocks when you're trying to get your project across the line. Obviously, it's lack of capital, slow decision making, uncertainty about the business case, and lack of internal experience to enable you to build those solutions. So the story coming through here is executing decarbonisation is not easy.
Yeah. Next one.
And sustaining those changes, this is really important as well, over the long term, is a struggle. So making sure that the changes that you make stick. There's nothing worse than investing time in building a solution and implementing a solution, only to turn around and see the benefit of that fading away over time. We all have experience of that happening, where set point changes are overridden because somebody has experience in a particular area and knows better than the recommendations. And suddenly you've lost a huge amount of benefit that you've won hard. So what we do, and Sean will talk about it in the demo itself, is we really help you understand your operational drift, to understand that those changes are being sustained.
Yeah, I mean, I think this is one of the biggest challenges that we see for our customers, in that a lot of the optimizations, a lot of the gains you can make are genuinely easily reversed. So if optimizations are coming from set point changes, or coming from regime changes with fridge plant or compressed air, and maybe they're working for 10, 11 months of the year, but there's a month in the year where environmental conditions are challenging a little bit, then sometimes they can get reversed and not put back into optimization mode, if you want to put it that way. So yeah, keeping the models and the eyes and the drift metric that looks at all of that is key for sort of locking those savings in for the long term.
And then scaling. So scaling across sites, this is hugely important in terms of getting that replicatable, scalable benefit. So it's a no-brainer. If one plant has developed expertise or experience in developing a solution and implementing that solution, the other sites should be able to benefit from it in an industrial context. But it's really been very surprising to us the extent to which that this doesn't happen. So that need to get it right, super important, but it doesn't happen. There isn't a formal knowledge base and repository of information within a lot of organizations, and that knowledge disappears. Maybe people exit the business, the expertise is gone, and everybody has to reinvent the wheel in each plant rather than benefiting from that knowledge and experience that happened somewhere else.
Yeah, again, we see this all the time. You know, you've got experts in certain areas in some plants, and they make great gains, but it's not transferring. You know, that the knowledge and the learnings post project are not documented and transferable. So that's part of that challenge, is trying to turn best practice, you know, into standard practice across the organization.
Great. So what we'll do now is Sean's going to speak about our Sparks framework. This is our approach to resolving and addressing some of those points. What I should have done at the beginning of this is I explained who I am and who Sean is. That was remiss of me, and had the webinar is going to move forward here. So I'm Keith. I'm responsible for the product and design team. So the product that will feature in the demo, I lead the team responsible for that.
And yeah, I'm Sean Doyle. I'm head of customer success and growth. And this protocol or framework, if you want to put it that way, is what we've developed to really tackle all of those challenges head on. As you can see, the acronym Sparks kind of clearly lays out that sort of protocol. So starting with, obviously, with that kind of challenge of sourcing your data from your industrial plants. That starts at the top down, you know, your high level utility data, main gas, elect, your main production data. How do you get all of that in and process it? You know, getting that in, being able to understand performance and using that data to understand what opportunities should be executed where, based on all the moving variables, is that sort of next phase. If you could do that with a very high degree of accuracy and integrity, then you're in a very strong position then to make decisions about what actions to take, what projects to pursue, what to engineer, and how we get from, an idea, if you want to put it that way, to something that's now in progress and is going to deliver a project. And again, into that sort of delivery phase, these types of projects are not that, always that simple or difficult, but they need to be engineered. It's not always let's take out one asset and replace it with a more efficient one. If you're replacing a gas boiler with an industrial heat pump, and you're trying to electrify your heat, it makes sense to try and prime that with waste heat maybe from somewhere else in the plant. So you've got a heat recovery project with a new asset and some engineering and ducting. All of that has to be kind of engineered and worked out. And then, as we kind of identified, making sure that these initiatives stay at kind of optimal mode and that you lock in the most efficient version of the result is key to maintaining that in the long term. And we've seen how that can kind of easily creep away. And I think when you really lock down that whole process from S to K, you can develop a best practice protocol, and you can take all of those learnings and bring them to the next plant. Let's not reinvent the wheel.
Yeah.
Start again. You've got all the gotchas, you've got all the challenges covered, documented, and the knowledge base created. And then you're sort of in that position then to start rolling out those types of opportunities across the enterprise. So what we'll do next, I guess, is
jump into a demo.
Yeah, and just maybe show how we support that entire process from end to end.
I think what we're going to do as well is we're going to leave maybe 5 minutes at the end here for your questions. You can enter your questions in the Zoom interface. We'll read them out. I'll read them out at the end, and we can address them, and we can take it from there.
Thanks, Keith. So this is a demonstration of what a typical account might look like for a global customer with sites, again, all over the world, Asia, North America, South Africa, Australia, wherever it might be, all again with different input variables around cost and emissions factors. So what we'll do next is have a look at the energy use and the profile of all these sites. We're going to start at this level with sort of global site metrics. So again, these are just the main incoming energies for these plants: main electricity, main gas, maybe there's other fuel like oil or diesel involved, and and from that a total energy value aggregated from all these sites. And then we bring in a sort of a production metric, whatever the most relevant output metric or input metric on production is across these sorts of sites.
And this can be customized for the whole interface, can be essentially customized in terms of significant energy users, which we'll get into in a couple of minutes as well, correct? And your production units as well.
Absolutely, yeah. So the underlying data, this is real time. This is not an end of month report or a BI report of some description. It's real time live data. And that you can see how you can sort of access that sort of data quite quickly behind all of these cells and tabs. What we then do is, convert this from an accounting point of view into scope 1 and 2 emissions. So we'll use whatever the relevant carbon emissions factors are around those locations globally and turn that into a table of carbon emissions, as you can see there. The next level, I suppose, of performance kind of review is to look at that sort of energy intensity metric. And again, this is pretty common and familiar in terms of taking an overall input like electricity or gas and then benchmarking it against the total product output. As you can see in this table, we're aggregating the average kilowatt hours per ton across all these sites. You can see there's quite a big variance on the electricity in terms of kilowatts per ton, almost 2x in some instances. And over here, we're getting a total energy product per ton kilowatt hours. Does this tell you anything about the performance of this plant? All it really does is say that this site uses more energy per ton of product, but everybody knows that there's nuances to why one site is more energy intense. Maybe at this time of the year, the energy and the weather is different. Maybe it's an older plant, all of that. So you need a little bit more and a little bit deeper insight to understand whether these sites are actually performing or not. And that's where we start to develop this operational drift metric, which is effectively leveraging an energy model to understand where energy is now, where a model would have predicted the energy should be based on the production, the weather, the inputs, whatever other variables you can put in. And that now tells us, where these sites are actually performing. So looking at this table, it might look like Tokyo is the worst performing in terms of benchmark. But if we look at here, what we can see is raw energy here, modeled energy here, and right here, we're seeing that 4 of these sites are actually performing better than the model. That means they're trending below. That means they're making improvements. They've set a baseline, and now they're trending 60 versus 63 expected. That's nearly a 5% gain.
So that challenge about the data only really getting you so far, and the fact that it's the insights and the meaning behind the data that really is important, is catered for in this particular area of the application.
Absolutely. And if what you're doing as an organization is publishing your targets, setting a 10% for every site, these are the sort of metrics that you need to really understand whether your portfolio is performing and every site is performing to their target. So you get to this sort of point, you see, okay, we're 5% over. You then want to know what's driving that. The input variables are not explaining it. So there's something happening inside a plant. That's where we want to go another level deeper. And we'll flick over to this global significant energy user tab. So again, for your comment, this is very customizable. In this example, we have 4 significant energy user groups: boilers, compressed air, HVAC, refrigeration, things that are typical across lots of domains and manufacturing environments. What you can see again is a similar format to the previous, where we've got raw energy like this, and we then go about the same methodology of looking to model these so that we can get really good performance, because all of these will have their own input variables and their own complexity. So if we could develop an energy model for each one of these, then we'll be able to scroll down. For example, here, this is the model version, and look at that operational drift metric at the SEU level. So we're 5% above on our total electricity. I'm looking now at Amsterdam to understand where that's coming from. I could see good performance in refrigeration, good performance in HVAC. Compressed air seems to be our problem.
Yeah.
Now, we've done a project on here. Why is that trending over and above? Maybe let's go back and have a look at the project itself in a little bit more detail, and maybe we have to develop a new opportunity to tackle this particular problem or challenge. That's where we start to register and start to create, the opportunities and the ideas that are going to address these challenges and operational drift metrics. As you can see here, the compressor optimization, I'll just click into that one. Well, before I do that, just to, I suppose, explain the construction of this and how it works. The register of opportunities at the very top, this is a master register for this organization. We can look at every single opportunity for every site. You could see the various currencies, carbon and energy metrics associated with those. I'm going to click into Amsterdam because that's where we had our example with our challenge on compressed air. If I click in here, you'll get a history of the project that was done here. So clearly there was sort of 3 initiatives developed to improve the demand for compressed air and the performance. And then you can see a sort of a history of the commentary where we have a dashboard. We seem to have lost savings, where we've identified a point at which we believe that the savings have started to slip, and we're having a dialogue, over and back with the site manager, Luis Suarez, to understand, what happened. It looks like, and if we flick over, we can see we have a lovely model here, and it looks like we've lost our savings at this point. We've drilled down a little bit, and now we're looking at the underlying compressors individually. And we start to zone in like at very granular 1-minute data. And we can see that there's a compressor here not performing. It's offload cycling, which is a very inefficient mode for a compressor to run in. And then we're feeding over and back, saying, why is this happening? There's different reasons for it. We've reduced the demand. Maybe we need to resequence compressors. A trial is run and off we go again. Savings are locked back.
So in terms of that challenge of scaling an opportunity, this is a huge repository of knowledge and insights and a communication thread that allows this same learning to be potentially utilized elsewhere in the business.
Yeah, absolutely. And it's a really good example of the interactive effects of when you go and change something somewhere. So we reduced the demand of the compressed air. And then the compressor that used to deliver that air was quite a big compressor. It didn't need to be as big anymore. So it started operating like that, which is quite inefficient. So now we have a a follow-on project, which is go back and look at the sequencing of that compressor house to better deliver that demand efficiently. So taking that learnings into the next phase is where we're going to go. So that's one opportunity within that overall register. We're quite down at the edge level. If you just maybe come back up 20,000 feet, maybe not that much, but have a look at the sort of the overall impact of all of the opportunities that are happening here. So obviously we could set our baseline for this site. This is the baseline. The green is that trajectory to our target here, and the blue is the estimated trajectory if all of those opportunities get delivered upon. This is another way of sort of navigating those opportunities. I can come in and see, well, what's happening here, and again, navigate it that way and cut out of it here and look at different projects and try to plan out for what needs to happen. So this site looks like it's got everything it needs to deliver on its goal, even though it looked a minute ago like it wasn't performing very well. Yeah. But that performance problem has been fixed, and we're sort of back on track again.
And it's another kind of window into your data and a way to interpret your data in terms of your likelihood of achieving your targets and the different initiatives you'll have to undertake to reach them.
Exactly. And the final thing, because we want to leave some time for questions, is again, coming up another level and saying, look, that's a single site's register of opportunities. That site's on plan, but we've got a lot of other sites here in the mix. Our total carbon baseline across the entire enterprise is 1.2 million tons. And this is like a summary view of all of the sites and the different stages that they have opportunities in. So again, if I'm in Amsterdam or I'm starting out in another site where I don't have as many projects developed, I can look and see how many projects are in progress in Dublin or in Amsterdam or Barcelona. I can look at the ones that have actually realized, click in and go, yeah, show me some of these, and what has happened and how they got on with those. And that's that kind of process again of scaling. This is the knowledge base. This is the brain trust, if you want, from
and the actual individuals down at an opportunity level are also visible. So if you need to get in touch with somebody or make a phone call and find out what they encountered on the ground, that's also possible as well, right?
Exactly. That's really how we're supposed, tech enabling this framework and this continuous improvement process. Again, it's about that foundation of data and strong informed decision making that really makes this thing work.
Great. Shall we see if we've any questions? And feel free to just add the questions into chat in your Q&A here. If you have any, we'd be happy to take them. Okay, so we'll read the question out, and I'll read the question out, Sean, and you answer it. So that's a fair division of responsibility, I think.
Yep.
So where can you pull the data from? A historian or OEM metering or cloud-based platform?
Yeah, good question. I go back to the sort of beginning. We can pull data from pretty much anywhere, and typically it is pretty much anywhere in every instance. So it's never one source. Sometimes we'll get main income or data from the utility API. Sometimes we'll get the process data, which is highly valuable, temperatures and pressures from a SCADA system or from a PLC. And then we'll get the energy data from a separate Modbus metering network. And in lots of instances, we will install and become the historian to gather a lot of that data. But in other instances on a data mature site, that's all sitting in a historian already. We just plug into that in a more advanced instance. Again, maybe all that data is already brought to a cloud, and all we have to do is access it from at a cloud level. So all sorts of different models and versions of accessing data, I think.
Okay, great. Next question then is, my plants produce different items. Can I categorize my plants into different buckets of categories? That's a really good question as well, I think.
Yeah, actually, maybe we didn't. We might have skipped over that in the demo. But if we just go back in quickly to show, we have a facility in this instance to group site filters. So it's a very important point, right? So lots of companies will produce lots of different products in different regions. So that for obvious reasons, they're not benchmarkable against each other. So maybe, and maybe you have sort of regional groups then who will be responsible for regional. So we can set this thing up by creating site groups, where we can define it regionally, or we can, make this a product-based site grouping, whatever is the most appropriate grouping mechanism is. We can set that up there, and then using that site groups filter, you can just basically filter all the results for one or other region or one or other type of product or site group.
Great. We have some other questions in here. What are the required field devices to generate the data?
Again, that they are varied in many, so sensors, temperature sensors, pressure sensors, valve position data, energy meters, power meters, airflow meters, steam meters, gas meters, all of that. And then critically, all the ways that production data can be kind of captured. Sometimes that's counters through a process. Sometimes it's information from SAP that we can get via file-based. So we get some data very fresh and live, 1 minute data 1 minute ago. Other data we might be getting through some sort of file transfer system on a daily basis. And that's, again, the varied process. So really, quite broad in range in terms of field devices. But
okay, great. Next question. What are the key enablers for the Cool Planet system? So I guess it's data, right? It starts with the data and then an understanding of how we connect that data. Is that fair?
It is a key enabler, yeah. But
yeah,
also the key enabler is, commitment, and a certain sort of readiness to tackle this. What we've presented here is a very top-down approach to doing that. So starting with main income or data at a high level and getting that right, and then disseminating down in. Of course, you could start from the bottom up, in terms of looking at a plant and digitizing it and bringing it up to standard. It's important to get the gaps identified and a program for filling those gaps so that you have, the standard that you need to deliver. So understanding, I guess, what you need is key. Data is clearly key, but obviously then, a commitment and
I guess stakeholder sponsorship as well,
exactly.
because it can answer a lot of questions and support a lot of different senior people in an organization, be it CSO, CFO, COO as well. So it's important to get all of the stakeholders sort of on board and supporting it.
Yeah, exactly.
Okay. There's a question here about connecting to brownfield manufacturing sites.
It has Orlan not connected to Elan.
Yeah.
I.e. in connecting to system on the Orland that is restricted to. That might be one we have to come back with. Maybe get technical support for that, but we'll take a note of it and who's asked the question, and we'll respond to that one later.
Right, that's why I'm asking the questions and you're answering them.
Yeah, or not.
I think we're almost at time. I think one thing we'd like to do is we'd like to circulate the presentation, obviously. The research that we undertook and we showcased at the beginning of the presentation. If you're interested in participating, we'd like to share that with you. We think it would be very valuable for both parties to give us an insight into what challenges you have, and obviously help to ensure that we're catering for your requirements when we're building our products as well. So we'd like to follow up with that. And if you've any further questions, I'm sure we can follow up on a one-on-one, including that Eland question for the brownfield manufacturing site. We'll take care of that one. And if you have any further questions, please just send them through. We'd be delighted to talk to you.
Great. Thank you.
Thank you.